So let's begin with problem 15. It says if A vector, B vector and C vector are unit coplanar vectors, unit vectors and coplanar, then the scalar triple product 2A minus B, 2B minus C and 2C minus A is equal to what? So obviously there can be, actually no, there doesn't seem to be many ways of doing this, but I'm sure there will be some simple way which will come out when we discuss about it, right?
Here it is given that A bar, B bar and C bar are unit coplanar vectors.
Correct.
So any linear combination of these three vectors will also turn out to be a coplanar vector to these vectors only.
Right.
So we can state that 2A bar minus B bar is coplanar with A bar and B bar.
Correct.
And C bar. 2B bar minus C bar is also coplanar with them. 2C bar minus A bar is also coplanar with them.
Right.
So we can say that the scalar triple product will turn out to be 0.
Okay, because it doesn't matter what those vectors are, if they are coplanar, the scalar triple product has to be 0 because the parallelepiped phi formed by those three vectors will have no volume. Exactly. So you see,
typical JEE question.
Exactly.
If you go on solving, then it will take you 5-7 minutes, and if you go by the basic, then you are in a second.
Okay, and it's not just the fact that it can be solved. People might think that there might be a trick, but most people will think of a lengthier trick. They'll be like, there might be some ways algebraically A, B, and C can be manipulated so that we arrived at these three vectors. Yes. But no, you don't actually have to. You just have to realize that these three are coplanar, and hence the volume of the parallelepiped will be 0, and since the triple product is 0.
Yes.
Okay, so that was the 15th problem, and we'll look at the 16th one now. So surprise, there is question 16 in vector algebra, and it goes like this. If P, Q and R are three mutually perpendicular vectors of the same magnitude, and if a vector x satisfies the equation P cross x minus Q cross P plus Q cross x minus R cross Q plus R cross x minus P cross R is equal to 0, then x is given by. So yeah, huge equation, 3 terms, and inside composite terms consisting of 4 vectors. Yeah, so please, how do we start?
So it is given that P bar, Q bar and R bar are three mutually perpendicular vectors, and it is also given that they are of same magnitude. So let us assume that magnitude of P bar is equal to magnitude of Q bar is equal to magnitude of R bar is equal to lambda, some constant.
Right.
And it is given that they are mutually perpendicular.
Okay.
So P bar dot Q bar is equal to Q bar dot R bar is equal to P bar dot R bar is equal to 0 vector. So it is given that the given equation P bar cross X bar minus Q bar cross P bar,
right,
plus Q bar cross X bar minus R bar cross Q bar,
okay,
plus R bar
which
cross,
is a cyclic expression actually, right?
Given equation,
right,
cross R bar, this is equal to 0.
Yep.
So now by vector triple product it will turn out to be P bar dot P bar,
okay,
times X bar minus Q bar,
treating X minus Q as one vector, right,
as a one single vector,
okay,
minus times P bar dot X bar minus Q bar,
okay,
times P bar.
Okay, so we'll do it only for the first term, and now we know for the
for all
term.
the 3 terms. We'll
okay.
Q bar dot Q bar times X bar minus R bar minus Q bar dot X bar minus R bar times Q bar,
okay,
plus R bar dot R bar,
okay,
X bar minus P bar,
right,
minus R bar dot X bar minus P bar,
okay,
times R bar.
Right.
This is turning out to be 0.
Right. Can you just put it there, the form of the triple product, so that people understand what is going on?
So what
A cross B cross C. Yeah.
If A bar cross B bar cross C bar is there,
right,
so its value turn out to be A bar dot C bar,
right,
times B bar,
okay, minus
A bar dot B bar times
C bar. Okay.
This is what basically I was using.
Yeah.
Now p bar dot p bar is mod p square, which
Correct.
turn out to be lambda square.
Right.
Lambda square times x bar minus q bar
Okay.
minus, or we can rather simplify it only. I will write the simplified form,
Okay.
which turn out to be 3 times x bar
Right.
times mod lambda square
Okay.
minus p bar plus q bar plus r bar
Right.
times mod lambda square,
Okay.
which is turning out to be x bar dot p bar times p bar
Right.
plus x bar dot q bar times q bar
Okay.
plus x bar dot r bar times r bar.
Right.
Here I have used two things.
Yep.
One is that the mod is lambda,
Lambda. Right.
and one more thing, that they are mutually perpendicular. So wherever it comes p bar dot
Okay.
q
All
bar.
dot products between p, q, and r are 0.
Yes.
Correct.
Exactly.
So.
Now the most crucial step of this question.
Okay.
We will be taking dot product with p bar on both the sides.
Okay.
So it turns out to be dot p bar
Right.
mod lambda
Because
square.
dot product is commutative.
And actually many terms will become 0.
Okay. And that is why we are doing this.
That is the catch in this question.
Okay.
So p bar dot p bar times mod lambda square will turn out to be x bar dot p bar times. So many terms have got reduced. Mod times p bar dot p bar.
Right.
But p bar dot p bar is mod lambda square. So again x bar dot p bar
Yep.
is mod lambda square minus mod lambda raised to power 4.
Right.
Will be turning out to be x bar dot p bar
Okay.
times mod lambda square.
Right.
Now lambda square will get cancelled. So we
Okay.
get 3x bar dot p bar
Right.
minus mod lambda square turn out to be x bar minus p bar.
Right. That's it.
Actually x bar dot p bar it is.
Yeah. Dot.
So will turn out to be 2 times x bar dot p bar will be mod lambda square. So x bar dot p bar will be mod lambda square by 2.
Right.
Now where we took the dot product with p bar,
Okay.
if instead of p bar we take q bar
Exactly.
or r bar,
Right.
we get the values of x bar dot q bar
Right.
and x bar dot r bar,
Okay.
which I have found, and they turn out to be x bar dot q bar comes out to be mod lambda square by 2,
Right.
and also x bar dot r bar.
Which is intuitive because there was no specificity about p. So
Yeah.
whatever we got for p, we had to get it for q and r.
Symmetry.
Right.
So we have got these values. Now we will be substituting these values again in the equation to which we took dot product of p.
Okay. So that equation was here.
This one.
Yep. Okay. So we'll rewrite the equation.
Yes,
Okay.
we'll rewrite the equation. So the equation was 3 times x bar mod lambda square minus p bar plus q bar plus r bar times mod lambda square. It was given to be x bar dot p bar times p bar plus x bar dot q bar times q bar
Right.
plus x bar dot r bar times r bar.
Okay.
Now these three values are given.
So we substitute all of them
Huh.
into this equation.
So it turned out to be p bar plus q bar plus r bar
Okay.
times mod lambda square by 2.
Okay.
So we get 3x bar times mod lambda square is turning out to be 3 by 2 times
Right.
p bar plus q bar plus r bar
Into lambda square, mod lambda square by 2.
into mod lambda square.
Okay, 2 we took outside.
Huh.
Right.
So x bar will turn out to be p bar plus q bar plus r bar by 2.
Right.
So it will turn out to be option B.
Okay. So let me just guide everybody through the solution because this is fairly long.
A quick review.
Exactly. Quick review. So since we were given P, Q, R are three mutually perpendicular, we always tend to try to use dot products. We always try to use dot products because we know they're 0 and it makes our job very simple.
Yes.
So we had to find the expression, the value of this expression, and we were given this expression is equal to 0. We need to find x vector.
bar.
Okay. So we took the expression and then we put them into the form of how we represent vector triple products.
Vector triple
And at that step itself, first of all, we put all dot products equal to 0 between P, Q and R. And then the resulting equation, we multiplied it, we took a dot product with P so that to simplify it. And then we reached at the conclusion that x dot p comes out to be mod lambda square by 2. And since there was nothing specific about p, we had to get the similar result about q and for r also. So we got these three values for x dot p, x dot q and x dot r. So we substitute all those values into the original equation which we got after simplifying the triple product. Okay, and then just simple like manipulation, nothing else. With just 2 steps, we got the answer. Okay,
Yes.
so here is something which is not a shortcut, which is not a quick trick. This is something, it's a lot of tricks actually. It's not just one trick, and this is a proper question, and solving this gives you satisfaction and it makes sure you know your concepts well. And this is how you can move from basic questions which we have been doing like till about 4 questions ago to advanced question in which we are actually using all of the same things, right?
Yes.
So, and that was the point of those questions. So we'll see the next one now. So question 17, it says if A vector, B vector and C vector are unit vectors, then what is the maximum value of mod of A minus B square plus mod of B minus C square plus mod of C minus A square?
Yes.
So it's a maximum value question. It's a fresh question now, and most people actually don't like to do some of these questions because they involve a lot of technical knowledge. But let's see how to go about it.
So it is given that we have to find the maximum value of mod of a bar minus b bar the whole square plus mod of b bar minus c bar the whole square plus mod of c bar minus a bar the whole square. It will turn out to be 2 times mod a square plus mod b square
Correct.
plus mod c square
Okay. And the rest of dot
minus 2
products.
times a bar dot b bar
Right.
plus b bar dot c bar
Okay.
plus c bar dot a bar. Now we have to somehow introduce some inequality,
Yep.
as we have to find the maximum value.
Correct.
So we will begin with this. Let us assume that a bar plus b bar plus c bar.
Okay.
We will square it. So what it will turn out to be mod a square plus mod b square
Right.
plus mod c square.
Okay.
I am doing the square because the value which we have to find concludes some such value
Okay.
such terms.
Correct.
Plus 2 times a bar dot b bar.
So when we say
Plus-
we're squaring a vector, we means taking a dot product to
Yes.
itself. Right.
Yes. C bar dot a bar. Now as it is given that there are 3 unit vectors.
Correct.
So mod a square plus mod b square plus mod c square
That is
will turn
simply
out to be 3
Right.
plus 2 times a bar dot b bar plus b bar dot c bar.
And I can see that there'll be a
Plus C
cos
bar
theta
dot-
and there'll be an inequality because of that.
Yeah.
Correct.
So as we can see that this LHS is always going to be greater than or equal to 0.
Right.
As it is a square, so it has to be always positive.
Right.
So from this we get an inequality.
Okay.
3 plus 2 times a bar dot b bar
Yep.
plus b bar dot c bar plus c bar dot a bar
Is always
is always greater than or equal to 0, which implies that a bar dot b bar plus b bar dot c bar plus c bar dot a bar
Is always greater.
it
than
is
minus
always
3 by
greater
2.
than or equal to minus 3 by 2.
Correct.
Now using this let this inequality be normed as equation 1.
Okay.
Yes. Now the value which we wanted to find was 2 times mod a square
Right.
plus mod b square plus mod c square minus 2 times summation dot products.
Right.
Now this will also be turned out to be 2 times this will 1 plus 1 plus 1 as
Correct.
they are given to be unit vectors
Right.
minus let it be now like this only
Okay.
a bar dot b bar.
Okay.
So it will turn out to be 6 minus twice summation a bar dot b bar.
Right. This is how we represent the sum of all dot products taken 2 at a time. Okay. So we have to find once again I'll let everybody know that we have to find the maximum value of this expression mod of a minus b whole square, mod of b minus c whole square, mod of c minus a whole square.
Yes.
Okay. Yeah.
So now it is given that from equation 1 we can say that the summation a bar dot b bar
Yep.
is having minimum value minus 3/2.
Okay. Because we concluded that just earlier in
Huh.
question 1.
Yeah. So as it is having the minimum value minus 3/2, so
Right.
minus times summation a bar dot b bar
Yep.
will have maximum value 3/2.
Correct. Because we can, when we multiply with negative sign, the inequality
Inequality
reverses.
changes.
Okay.
So minus 2 times summation a bar dot b bar will have maximum value 3.
Right.
So the value which we wanted, that is a bar minus b bar square plus mod of b bar minus c bar the whole square plus mod of c bar minus a bar
Whole square.
square
Right.
will turn out to be less than or equal to actually
Yep.
6 plus 3.
Right.
Huh.
So which is
So
9.
less than or equal to 9. So maximum value will turn out to be 9.
Right. So this question was exactly what it looked like. It involved work, and let me guide you how that was done. First of all, the expression which we had, we tried to break it into magnitudes and dot products, because magnitudes we can just put that 1 because they're all unit vectors.
Yes.
So we did that, and then we obtained, since we had squared a vector, so the right hand side always had to be positive,
Yes.
or actually non-negative.
Huh.
And then we concluded that because of that we got a condition for the sum of dot products taken two
Yes.
at a time. We got an inequality for that.
Huh.
And after that what we did was
We wanted to find the value of that mod a minus b the whole square plus mod of b minus.
right.
So we wrote it like that: 2 times mod of a bar plus or mod of b bar plus mod of c bar,
okay.
and minus
And
2
then
times
okay,
summation dot
and then we
product.
used the same inequality in the expression which we got it from actually,
Yes.
right?
Huh.
Before squaring.
Yes.
Okay, and that led us to the conclusion that this whole expression has a maximum value of 9.
9. Yes.
Okay, so that was question 17.